Assalamu alaikum. We were studying catalysis in the previous lecture, a topic of surface chemistry. We had studied that there are 4 types of catalysis. First one, homogeneous catalysis, which we had discussed already, that it is a type of catalysis in which the reactants and the catalyst, they exist in same physical state, and we had mentioned the examples. The first example was the decomposition of potassium chlorate solid in the presence of MnO2 as catalyst, manganese dioxide solid as catalyst. Second example which we had quoted was the nitration of benzene with concentrated nitric acid in the presence of concentrated sulfuric acid as catalyst. Both the benzene and sulfuric acid exist as liquids. The third example was the lead chamber process for sulfuric acid, in which sulfur dioxide gas is oxidized reversibly to sulfur trioxide gas, and the catalyst used in this case are the oxides of nitrogen, nitric oxide and nitrogen dioxide or nitrogen peroxide. The reactants are gases and the catalysts are also gases. More examples can be given. For example, the formation of esters by the reaction of carboxylic acids, which are liquids, carboxylic acid and alcohol in the presence of sulfuric acid of concentrated H2SO4. The reactants are liquid, carboxylic acids and alcohols are liquid, and concentrated sulfuric acid also act as liquid. And the last example which we can quote is the inversion of cane sugar by acids like HCl. Cane sugar or sucrose is dextrorotatory. When it is treated with acids like HCl and kept for longer period, it undergoes hydrolysis to produce glucose and fructose. Glucose is dextrorotatory while fructose is more levorotatory. As sucrose produces a more levorotatory fructose, therefore the direction of rotation changes from dextro to levo, and this phenomena is known as inversion. Now in this case, sugarcane solution is in the liquid phase, water is liquid, and the catalyst, which is HCl, is also in liquid phase. Now we discuss the second type, which is known as heterogeneous catalysis. It is a process in which the reactants and the catalyst, they exist in different physical states. The reactants and catalyst exist in different physical states. It is a process in which the reactants and catalyst exist in different physical states. In Greek, hetero means different and genus means composition. They have different composition. The reactants and catalysts have different composition. Examples of heterogeneous catalysis are: first example is the hydrogenation of oil to ghee. Oils can be converted into ghee by passing hydrogen gas in the presence of nickel. hydrogenation of oil to ghee in the presence of nickel catalyst. Oils are liquids. When we pass hydrogen gas through them in the presence of nickel catalyst, which may be used as nickel formate, then we get ghee, which is solid. Now in this case, oil is liquid, reactants are liquid and gas, while the catalyst is in solid state. Second, Friedel-Crafts reactions, Friedel-Crafts alkylation reactions of benzene. Friedel-Crafts alkylation as well as acylation are also an example of heterogeneous catalysis. In Friedel-Crafts alkylation, benzene, which is in liquid state, is treated with alkyl halides, which are also in liquid phase, in the presence of aluminium chloride or boron trifluoride or any Lewis acid, which are in solid state and act as catalyst, and we get alkyl benzenes. Now in this case, the reactants are liquid and the catalyst is a solid. So it is an example of heterogeneous catalysis, A and B, second example. The third example of heterogeneous catalysis is the polymerization of ethene to polyethylene. Third example is the polymerization of ethene to polyethylene by using Ziegler-Natta catalyst. Ziegler-Natta catalyst is a mixture of titanium tetrachloride and triethyl aluminium C2H5O3Al. Both are solids. Now if we have n molecules of ethene, n may be 400 or 500, and we pass this gas over the catalyst, which is titanium tetrachloride and triethyl aluminium, then we get polyethylene, which is a multi-purpose plastic. Now in this case, the reactant is gas and the catalyst is a solid. Next example which can be quoted is the contact process for sulfuric acid. Sulfuric acid can be manufactured by contact process, and in this process the main reaction is the reversible oxidation of sulfur dioxide to sulfur trioxide. SO2 is treated with oxygen to produce sulfur trioxide, and the catalyst used is vanadium pentaoxide, which is a solid. Now in this case, the reactants are gases while the catalyst is solid. Platinum can also be used, but V2O5 is preferred in this case because V2O5 is cheaper and it is not readily poisoned by the impurities in the feedstock. The third type of catalysis is known as enzyme catalysis. Enzyme catalysis is a process which is catalyzed by enzymes. A biochemical process which is catalyzed by enzymes is known as enzyme catalysis. For example, different enzymes can cause the breakdown of different biomolecules. For example, carbohydrates can be hydrolyzed by the enzyme diastase or amylase or tylines to produce glucose. Proteins are hydrolyzed by the enzymes proteoses like pepsin, renin. Renin is an enzyme which is particular for digesting mammal's milk. Now pepsin and renin, they break the proteins, they cause hydrolysis of proteins to produce amino acids. The fourth type of catalysis is known as autocatalysis. Fourth type of catalysis is known as autocatalysis. Let us suppose we have a reactant A which changes into a product B, and the product B also act as catalyst. It can act as a catalyst and it speeds up the further reaction, and the next reaction can be written as A plus B is equal to 2B. Now B is acting as catalyst and it converts A into B, therefore we get A plus 2B is equal to 2B. So such reactions in which one of the product formed during a chemical reaction itself act as a catalyst and speeds up the further reaction is known as autocatalysis. Examples of autocatalysis are: first example, the oxidation of oxalic acid by acidified potassium permanganate produces manganese sulfate, which contains Mn+2 ions in the product. Oxalic acid, when oxalic acid is treated with potassium permanganate and sulfuric acid, we get many products, but one of the product form is manganese sulfate, which contains Mn+2 ions, and these Mn+2 ions, they act as autocatalyst and they further speed up the oxidation of oxalic acid. The main reaction, the parent reaction which takes place is 5H2C2O4, it is oxalic acid, 5 moles of oxalic acid plus 2KMnO4 potassium permanganate plus 3H2SO4, we get K2SO4 potassium sulfate plus 2MnSO4 manganese sulfate plus 10CO2 plus 8H2O. Now in this case the manganese sulfate which is formed, it can act as autocatalyst and the reaction is speeded up after some time. Second example is the hydrolysis of aspirin. Aspirin is acetyl salicylic acid. When it is treated with water, it undergoes hydrolysis and produces salicylic acid and acetic acid. Now this acetic acid, which is a carboxylic acid, when it is formed during the reaction, it acts as autocatalyst and speeds up the further reaction. The reaction is, the main reaction or the actual reaction is, it is the formula of acetyl salicylic acid. It is acetyl salicylic acid or aspirin. When it is subjected to hydrolysis, when it is treated with water, it produces salicylic acid and acetic acid. Now this acetic acid acts as autocatalyst and it speeds up the further reaction. So in the initial stages, the reactions which are autocatalyzed, they will be slow, but as soon as the product is formed which is acting as a catalyst, the reaction will be speeded up. So these are the 4 different types of catalysis, that is homogeneous catalysis, heterogeneous catalysis, enzyme catalysis and autocatalysis. Allah Hafiz.